Somewhere in America right now, there is a 1967 Chevrolet Camaro sitting in a private garage. It looks perfect. Show quality. Numbers matching. But if you walked up to that car with an ultrasonic thickness gauge and ran it across the door panels, across the roof, across those beautiful quarter panels, you'd find metal so thin you could almost push your thumb through it. That car didn't start out that way. It started out as a weapon, built by men who looked at the rule book and saw a suggestion. Today we're going back to the 1960s. To the smoke-filled garages and back-alley dyno rooms where the fastest drag cars in America were born. We're going to talk about acid dipping, about fuel hidden inside the frame itself, about tricks so clever and so dangerous that NHRA inspectors had to invent entirely new technology just to catch them. Some of this was genius. Some of it had people killed. All of it changed drag racing forever. Let's get into it.
Before we get into the
secrets, you have to understand the world these men were living in. Because the cheating didn't happen in a vacuum. It happened because the stakes were unlike anything the sport had ever seen before or since. The 1960s was the golden age of American muscle, and I don't use that term lightly. Ford, General Motors, Chrysler. They were locked in one of the most expensive, most public, most personal rivalries in American business history. And drag racing was their battlefield. See, Detroit had figured something out early in the decade. When a car won at the drag strip, when it beat the competition in front of thousands of fans, the sales numbers at the dealership moved. Not a little. A lot. The Pontiac GTO became a legend, not just because of what it did on the street, but because of what it did on the strip. The Ford 427 got its fearsome reputation because racers saw what it could do in competition before they ever sat in a showroom. This was the era of the factory-sponsored race car, the superstock class. Cars that wore dealership paint schemes and carried factory engineering support but ran times that had nothing to do with what you could buy off the lot. And the factory money? It was flowing. Ford's Total Performance campaign was spending millions. Chrysler had Ronnie Sox and Buddy Martin. GM had its fingerprints all over cars it officially had nothing to do with because of a corporate ban on factory racing that everyone knew was being ignored. The pressure on the teams that ran these cars was immense. You didn't just race for a trophy, you raced for a contract, for next year's engine program, for a phone call from Detroit that could change your life. And when the difference between winning and losing is measured in hundredths of a second, men do things they wouldn't otherwise do. The rulebook was clear, but the desire to win was clearer. And somewhere in that tension, the most creative cheating in motorsport history was born. Now let's talk physics for a minute. Don't worry, I'll keep it simple. In drag racing, your performance comes down to one basic equation: power versus weight. More power, more speed. Less weight, more speed. It's that simple. The legal ways to reduce weight on a race car were well established by the early 1960s. Teams were already doing all of them. Fiberglass hoods and front fenders instead of steel that could save you 60 to 80 pounds right there. Lightweight plexiglass windows instead of real glass. Another 20 pounds, gutting the interior. No carpet, no headliner, no back seat, no door panels. Strip it to bare metal, another 50 to 100 pounds. Aluminum bumpers, drilled components, titanium fasteners where you could get them. By the time a serious superstock team was done with the legal stuff, they'd already pulled 300 to 400 pounds off what came from the factory. But here's the thing, every team was doing those same tricks, which meant none of them had an advantage. When everyone is doing the legal stuff, the man who wins is the one who found something the rulebook didn't think to cover. And in the 1960s drag racing, the rulebook had a gap big enough to drive a funny car through. It said plenty about what you could do to a car. It said very little about what you could undo. That gap between action and omission is where the acid came in. Acid dipping. The term sounds simple. The reality was a precise, dangerous, highly skilled process that required real engineering knowledge to execute correctly. Let me walk you through how it actually worked. Step 1. You start with the body panels. In most cases, teams would strip the entire body doors, hood, trunk lid, roof skin, quarter panels, even the floor pan in some cases, and address each panel separately. The most common acid solution used was a caustic alkaline bath or an acid solution with a controlled concentration. Some teams used hydrochloric acid, muriatic acid diluted to a specific strength. Others used sodium hydroxide solutions. A few of the more sophisticated operations they developed through trial and error. The panel would be submerged completely, held with non-reactive supports, and left in the bath for a carefully timed period. Too little time? You didn't lose enough weight to matter. Too much time? The panel came out so thin it was useless, or worse, it became structurally unpredictable. You wouldn't know it had failed until it failed at 130 miles an hour. The most. Skilled operators could reduce panel thickness from the factory standard of 0.036 inches down to as little as 0.016 to 0.018 inches. That's less than half the original thickness. Now, here's where the real engineering came in. You couldn't just uniform dip every panel. Different parts of the car had different structural requirements. The door skin could go thin, but the door frame, the part that actually holds the door and contributes to the roofline structure, needed to stay closer to spec, or the door would sag and bind. The hood could get extremely thin on the flat surfaces, but around the hinge points and the latch area, you needed more material, or the hood would warp and flutter at speed. The best acid dipping specialists, and yes, there were specialists, men who did this for a living, they knew exactly which areas to protect with wax or chemical resist, and which areas to let the bath work on fully. It was, in a twisted way, an art form. The weight savings were staggering. A team that successfully acid dipped the full body of a mid-size muscle car could realistically remove 150 to 250 pounds compared to the stock steel weight. In quarter-mile performance terms, every 100 pounds of weight reduction is worth roughly 1 to 1.5 tenths of a second in elapsed time. Do the math, a quarter second. On a run where races are decided by hundredths, that's not just an advantage, that's dominance, but it came at a price. The cars were fragile in ways that spectators couldn't see and drivers couldn't feel until it was too late. In a racing incident, a spin, a wall contact, even a hard landing off the timing lights, those thinned panels didn't behave the way engineers had designed them to behave. Steel absorbs and redirects crash energy in a predictable pattern. Engineered crumple zones, even the primitive ones of the 1960s, depended on metal of a certain thickness. Acid-dipped panels didn't crumple. They collapsed. They folded. They sometimes pierced inward. There were serious injuries connected to cars that later showed evidence of body thinning. Nobody talked about it publicly at the time. Racing deaths and injuries in the 1960s were far more common than they are today. And the connection between thinned bodywork and injury severity was not something the racing community was eager to advertise. But the people who knew, they knew, and most of them kept winning anyway. Now, if acid dipping was clearly illegal, and by the mid-1960s, NHRA rules were explicit about minimum panel thickness, how did teams keep getting away with it? Simple answer, they were smarter than the inspectors, at least for a while. The most basic concealment technique was cosmetic. After the acid bath, the panel would be media blasted clean, then sprayed with a heavy application of primer surfacer, sometimes 2 or 3 coats, then body filler in strategic spots, then more primer. The finished surface looked factory, felt factory, and if an inspector used a simple contact gauge, the kind that measures from the outside surface, it could read close enough to spec that nothing triggered a rejection. The problem was the seams. Where a panel meets a structural member, where the skin meets the frame or the inner structure, the thinned metal created visible gaps, irregularities or witness marks that a trained eye could spot. So the better operations learned to address those areas specifically. Filler in the seam gaps. Careful. Blending. Matching the factory undercoating texture with spray-applied rubberized compound. At a glance, even from 6 inches away, those cars looked stock. The second layer of concealment was strategic, knowing which panels to dip and which to leave alone. NHRA inspectors at a regional event were checking dozens of cars under time pressure. They had priorities. They focused on the panels that were easiest to access and most likely to have been modified. Teams learned which panels inspectors always checked, and they left those panels at or near legal thickness. The roof skin? Rarely checked in detail. Dip it. The inner floor pan areas under the carpet location? Almost never probed. Dip it. The door skins on the B-pilar side? Hard to gauge properly with a contact tool. Dip them. The front fenders and hood, inspectors loved those. Leave them close to legal. It was an exercise in risk management. And then NHRA changed the game. In the late 1960s and into the early 1970s, NHRA Tech officials began deploying ultrasonic thickness gauges, the same technology used in aerospace and shipbuilding to check material thickness without cutting into it. Press the sensor against the surface. It sends a pulse through the material, measures the return time, calculates thickness to within thousandths of an inch, and it didn't matter how much primer was on top. The first time a tech inspector ran one of those devices across a panel that had been dipped and beautifully refinished, watched the number come up at 0.019 inches instead of 0.036. The look on that crew chief's face must have been something. The technology arms race had begun, and the cheaters were no longer winning it. All right, let's move from the body to the frame. Because if acid dipping was bold, what some teams did with their fuel systems was genius. Absolute, rule-breaking, possibly criminal genius. To understand this, you need to know how fuel class rules worked in NHRA competition during the 1960s. Your class was determined by several factors: engine displacement, car weight, and fuel type. Gasoline classes ran gasoline. Alcohol classes ran methanol blends. Nitro classes ran nitromethane. The performance difference between these fuels is enormous. Nitromethane, the stuff top fuel cars run today, produces roughly 8 times the power output per unit volume compared to gasoline. You read that right, 8 times. Even a relatively mild nitro blend, say 15 or 20%. Nitromethane mixed with methanol would give a gasoline-class engine a massive, illegal, completely unmistakable power advantage. The problem, of course, is that you can't just pour nitro into your tank and roll up to the tech line. Inspectors test fuel samples. They have chemical analysis tools. A nitro-contaminated fuel sample glows like a neon sign. So how do you get the good stuff into the engine when the inspector has already seen clean pump gas in your tank? You hide the real fuel. Somewhere the inspector isn't looking. And on a 1960s American body-on-frame car, the frame itself was hollow. I want you to really think about the engineering here. A typical full-frame American car of that era used rectangular or boxed steel frame rails running the length of the car. These rails were structural. They carried the weight of the engine, the body, the drivetrain. But they were hollow, sealed steel tubes. What if those tubes weren't just structural? What if they were also a fuel delivery system? Here's how the setup worked, based on accounts from mechanics who were involved or witnessed it. The team would machine custom end fittings for the frame rail, threaded ports that could be opened and resealed. These were installed when the car was built or converted and finished in a way that made them look like factory welds or drain plugs. Inside the frame rail, they would run a lightweight fuel line thin enough to not significantly restrict the interior volume, but adequate to flow fuel at the volumes needed for a short quarter-mile run. A hidden switching valve, sometimes pneumatically actuated, sometimes cable-operated from the cockpit, would sit in a location that wasn't part of the standard inspection checklist, behind a body panel, inside the firewall area, under the car in a spot that required a lift to access properly. Before tech inspection, the visible fuel system shows clean gasoline. The inspector samples it, checks the carburetor bowl, ticks the box. After the car leaves the tech line and before it stages, the driver or a crew member activates the valve. The engine is now drawing from the frame rail supply the good stuff, the nitro blend, the mixture that's going to light the tires up and run a time that shouldn't be possible. The run happens. The clocks stop. The time is on the board. By the time the car reaches the other end and rolls back, the valve has been switched back. The frame supply is isolated. Everything shows normal. Again, the inspector who rechecks the fuel still sees gasoline. This wasn't a one-time trick by one clever crew. There were multiple teams across multiple sanctioning bodies, not just NHRA, running variations of this system through the mid to late 1960s. The evidence was in the times themselves. Cars that were running consistent, legitimate numbers in one class suddenly at key national events posting times that defied the physics of what their class should be capable of. Sometimes it was obvious enough that competitors filed protests. But without knowing exactly what to look for, inspectors couldn't find the evidence. It was only when someone from inside the world, a rival crew chief who'd heard enough rumors, a disgruntled mechanic who'd worked on one of these cars, went to NHRA officials with specific, detailed information that the searches became targeted enough to find the installations. When they finally did find a frame rail fuel system on a car that had been winning, the sport changed overnight. NHRA mandated detailed frame inspections. Hollow sections had to be probed. Any fittings, welds, or ports that weren't clearly factory equipment required documentation. Cars that couldn't explain their frame modifications were disqualified, and their recent results were reviewed. The window had closed. But the runs those cars had made, those times were already in the record books. And some of them stayed there for years. Other dirty tricks of the era now, Acid. Dipping and hidden fuel lines were the most notorious tricks of the era, but they were far from the only ones. The 1960s drag racing scene was an absolute encyclopedia of creative rule interpretation. Let me give you a few more that'll make you appreciate just how inventive these guys were. The Ballast bait-and-switch weight minimums were enforced at the scales. Your car had to meet a minimum weight for its class. Some teams would show up to tech with lead ballast bolted in obvious locations. Under the car, in the trunk. Inspector weighs the car. It's legal, he moves on. The lead? Gone before the car stages. Hidden compartments. Quick-release brackets. Sometimes just handed to a crew member who walked it off while the car was pushed to the line. The car that passed tech at legal weight ran the quarter mile potentially 50 to 80 pounds lighter. The tire trick. Tire rules specified approved compounds and minimum widths. What the rules didn't initially specify clearly was tire pressure at the time of measurement versus at the time of the run. A tire inflated to high pressure looks narrower, passes the width check. Run it at lower pressure, tread spread increases, contact patch grows, traction improves. Simple, elegant, technically arguable. NHRA eventually specified that tires would be measured at race-ready pressure. Problem solved. But not before plenty of teams had used it. The engine displacement game class rules were based on cubic inch displacement. Your engine had to be within the declared displacement verified by bore and stroke measurements. Some engine builders got extraordinarily creative with their measurement compliance. Pistons with unusual dome profiles that technically measured within spec at the gauge points the inspector checked, but displaced differently in actual combustion. Bore measurements taken at locations that showed legal dimensions while the actual swept volume came in over the limit. This required a machinist of exceptional skill and a very thorough understanding of exactly what the inspection procedure checked and where it didn't. The clutch can and the flywheel hide automatic transmission cars in some classes were required to have stock or stock-appearing converter and flywheel assemblies. Racing spec torque converters stall higher, transfer power more efficiently, but they weren't legal in certain classes. Teams would install race converters that had been machined and finished to look externally identical to stock units. Same dimensions, same appearance, completely different internal geometry. Unless an inspector pulled the transmission, which nobody had time to do at every event, the modified unit looked legal. Every single one of these tricks, the ballast drop, the tire pressure game, the displacement manipulation, the fake converter, shared the same DNA as acid dipping and the frame fuel lines. They all came from the same place. Men who understood the rules so completely, so deeply that they could find the space between what the rules said and what the rules meant. That's a specific kind of intelligence. And in the 1960s, that intelligence built some of the most legendary cars in American motorsport history. I want to slow down for a moment, because it's easy to tell this story as a list of violations, rules broken, cheaters caught, bans handed out. But that's not really the story. The real story is about who these men were, where they came from, what drag racing meant to them. Most of the crew chiefs and car builders who ran these tricks in the 1960s were not wealthy men. They weren't backed by corporations or trust funds. They were machinists, factory workers, small business owners who ran a garage during the week and raced on weekends. Many of them had grown up during the Depression. They knew what it meant to have nothing, to make something from nothing. They had come home from World War II or Korea with a different relationship to rules and authority than previous generations. They'd seen what the world actually was. They weren't naive about the gap between what was supposed to happen and what actually happened. and they had an intimate personal relationship with machines, not academic, not theoretical. They had learned engines the way you learn a language, by being immersed in them, by touching every part, by understanding not just what a component did, but why it did it, and what would happen if you changed it. That knowledge was their power. In a world where class background and formal education determined most things, knowledge of a machine was a pure meritocracy. The fastest car won, period. And the men who built the fastest cars, whether they built them legally or otherwise, earned a status in their communities that no amount of money could buy. I've spoken with mechanics from that era, men now in their 70s and 80s who were in those garages. And when you ask them about the acid dipping, about the frame tricks, they don't defend it exactly, but they don't apologize either. The look they get is something between pride and nostalgia. We did what we had to do, one of them told me. Everybody was looking for an edge. We just found a better one. Another one said something I've never forgotten. The rulebook told you what you couldn't do. It never told you what you could. We just read the spaces between the lines. Read the spaces between the lines. That's a pretty good way to describe 1960s drag racing. And honestly, it's a pretty good way to describe America in the 1960s. How the cheaters made drag racing better. Here's the part of this story that most people don't think about. All of this cheating, the acid dipping, the hidden fuel, every dirty trick we've talked about today, it made drag racing better. Not despite what it was, because of what it was. Think about how NHRA tech inspection works today. Digital scales with data logging, ultrasonic material analysis, fuel, spectrometry that can detect chemical compositions at the parts per million level, computer map displacement verification, frame inspection protocols that require documentation for every non-factory weld. None of that technology would exist in drag racing, at least not this early, if teams hadn't forced the sanctioning bodies to develop it. Every time a team found a way around the existing inspection protocol, NHRA had two choices: accept the cheating or invent a better way to catch it. They almost always chose to invent, and each invention raised the overall sophistication of the sport, the level of engineering rigor, the precision of the competition. The acid dippers didn't just thin metal. They forced the development of non-destructive testing protocols that are now used in every serious motorsport worldwide. The frame fuel line conspirators didn't just hide nitro. They forced the creation of detailed chassis documentation requirements that made car building more systematic and verifiable across the entire sport. The tire pressure manipulators created standardized pre-race tire inspection that made competition more fair for everyone. Every closed loophole made the game cleaner. And the men who found those loopholes, some of them are in the Motorsports Hall of Fame. Their cars are in the NHRA Museum in Pomona. Their names are on buildings and trophies and sponsorship banners at national events. The sport didn't erase them. It absorbed them because it understood. Even if it never said it out loud, that the line between genius and cheating in motorsport has always been thin, about as thin as an acid-dipped door panel. That's the full story of acid dipping and the hidden frame fuel lines, the dirty secrets that the teams buried, the tricks that NHRA hunted, the engineering that was brilliant and reckless and deeply, completely American. If you lived through this era, if you were at Lyons Drag Strip or US 30 or Pomona in the 1960s, you were watching history happen. You may not have known all of what was going on under those hoods and inside those frames, but you knew those cars were something special. Drop a comment and tell me your story. What did you see?
What did you hear?
What did the old-timers tell you about the tricks of the trade? I read every comment, and the best ones might end up in a future video. If you enjoyed this one, hit that subscribe button, because we have a lot more where this came from. Next week we're going inside the tunnel ram intake wars of the early 1970s, factory teams, backroom deals, and an engine combination that Chevrolet officially never built, but somehow ended up in 300 race cars. That story is something else. Until then, keep the rubber side down. I'll see you at the starting line.